Hi, my name is Brad Dodgerell. My colleague Paul Williams and I will be walking through automating advanced analytics, a full lifecycle approach to fraud intelligence generation. One of the interesting things about the fraud domain is that it's so correlated with companies' product strategies. So whether rolling out new products or rolling out new channels for existing products, all of those are going to increase the chance of vectors in which fraud can happen to that institution. And it really doesn't matter the product specific. So whether it's consumer loans or deposits or card, which is the focus of this presentation, we see the same phenomena. The chart below kind of shows really these increases of fraud across this decade into the next. So while the relative fraud losses are constant, as shown in the red graph, the one that's bigger concern is really the blue chart. So it shows through 227 that card fraud is going to continue growing. And as you know, card transactions are forecasted to continue growing as well. There's no reason to believe that the fraud losses on the card space will not continue at the same rate. And the problem is on the financial institution side, the people that are tasked with stopping this fraud are not growing at the same rate. So they're going to have to become more efficient and have better techniques to catch the fraud. And that's where some challenges pose themselves. So really the first is the dynamics of fraud itself. So when a solution goes into production, that solution is going to be its very best that first day. And then what's going to happen is the fraudsters are going to change his or her tactics, and you're going to see the solution start to degrade. So it's a very kind of big game of cat and mouse. The second is the class imbalance. So fraud is, or at least should be, a rare event. And no matter if you're looking at it as fraud events per number of transactions or fraud dollars per transaction dollars, it is very rare. And special attention needs to be paid to be able to handle those type of events. And the last is the technique. So there's tons of technique decisions on how you want to kind of model fraud. So whether it's supervised versus unsupervised, inferential versus predictive, or rules versus models, the right decision is really needs to be made when you're talking about how to set up your analytical strategy. And our institution has had these exact same challenges, and we've had to go through these exact same conversations. And the one today we're going to focus on is really the last one, the rules versus models. And so what we found is that really the solutions complement each other, right? So we have both rules and models. And on the model side, right, you're able to uncover some really complex fraud relationships from having kind of one central solution. And that solution is able to kind of automatically detect fraud changes as they're happening. But all that benefit, really you kind of lose some of the benefits that you have on the rules side. So for instance, where rules, you can implement them very fast. Models does not have that luxury. Usually there's a longer timeline there. The rules are easier to understand. Models can be black box in nature, kind of depending on the functional form. And on the rules side, there's really not the same governance requirements that you have on the model side. And so really coming out of the financial crisis and with SR 11.7 models really we're starting to require a lot of documentation. And so kind of the question that Paul and I posed to ourselves was, is there a solution that we can create that really kind of takes the best of both worlds, right? It kind of takes all the benefits of rules and all the benefits of models and doesn't have as much of the downside. And so that's what we're going to really deep dive today, is the hybrid approach. And I'm going to hand it off to Paul here, and he's going to really walk through our hybrid approach and how it covers these 6 pillars.
In terms of the advantages of both rules and models. And specifically, our team has historically focused primarily on machine learning types of solutions. And so a lot of what we've done here is kind of bring in ideas and techniques from emerging research in the machine learning, specifically automated machine learning literature, and tried to see how we can apply that to automating the process of creating rules, evaluating their performance, and in general, maintaining a good performing system of rules over time. And so this hybrid approach is built around 6 pillars, as Brad mentioned. And what I'm going to do is talk through, for each of these 6 pillars, a couple of the ideas and approaches that we've found to be most useful in pursuit of this hybrid approach. So the first pillar is targeted trends. And this gets at the point that Brad mentioned around the adversarial and kind of dynamic, ever-changing nature of fraud. And also the fact that we have teams of rule analysts that are able to leverage a lot of expertise and also industry knowledge around what are the kinds of patterns that are being seen across the financial industry or across industry more generally. And so the idea here is that instead of just training a model to do all of the rule creation by itself, to really couple the model to a rules analyst and really empower the rules analyst to leverage this automated machine learning technology in a way where they're able to guide it and focus it on specific trends as they're emerging. And then the second idea around targeted trends is a technique that's very well known and well established within machine learning, which is hyperparameter optimization, or grid search being one prominent method for this. But basically the idea being there's a lot of different ways of configuring rules or models. In the rules cases, you need to select thresholds for, what is the transaction amount that represents sufficient risk? How do you incorporate risk scores and so on? And by leveraging these kind of automated methods from machine learning, we can much more efficiently iterate through many different possible combinations and in the end find that kind of golden needle in the haystack in terms of the best solution there. And then the second pillar has to do with speed to market. And as Brad touched on, historically, this is where rules really have the edge over models. In particular with model development, there's traditionally been this long timeline of steps that you see depicted on the slide, where you have to prepare your data, train models, do model selection, and then often iterate that entire approach. Whereas with rule-based systems, they're really designed to kind of stop the bleeding, be able to put in solutions to mitigate risks quickly. And so what we've tried to bring in here are ideas from automating this kind of machine learning process in general and kind of building pipelines that can handle a lot of this work in a repeatable, automatic fashion, and apply that again to the rule creation process. So try to build out automated machine learning pipelines that in the end are going to produce recommendations for rules that would be good to put in for emerging trends. And then the second idea around the pillar of speed to market is continuous delivery. And this is a concept from kind of modern software engineering practices, but essentially the idea being our goal is that once the machine learning solution makes recommendations to a rule analyst, as these seem like they're targeting the trend that you want to stop, all that the analyst has to do at that point is essentially review those results. And if they agree with it, it's a one-click deployment process. So they can very quickly put this into production. And then the next pillar is explainability. And again, this is another area where rules are kind of held up as almost quintessential examples of explainable methods, because you can essentially directly inspect the logic of the rule and understand how the decision is made. But what we found is that in practice, explainability is a much more challenging and elusive goal. And in particular, with these production rule systems, they're often organized into complex hierarchies of rules nested within rules, and then also applied in different ways to different segmentations of our membership. And so in the end, actually understanding how the decisions get made is far more challenging than it at first appears. And so the ideas that we've applied here, again, coming from the machine learning literature, specifically around kind of decision tree methods. The first has to do with pruning. So basically techniques for once you've created a decision tree or a rule, how do you try to simplify that down to capture kind of the essence and also improve generalization by doing so. And then the second idea is, again, applying this idea of how do we simplify things, but at a higher level up. So looking at the entire system of rules, applying optimal subset selection techniques. So basically, how do we choose the best subset of rules that gives us overall performance and generalization? And then the next pillar, closely related to the previous one, is observability. And this has to do with really how well are analysts able to understand how the current rules are performing, and in particular, able to effectively and efficiently identify opportunities for improvement there. And so a couple of approaches that we've found really powerful here is the first enabling analysts to do drill down analysis. So to basically be able to start from how is this entire system of thousands of rules performing all together, and then be able to drill down to individual rules nested within those rules, all the way down to even atomic level kind of conditions. And then the second idea for observability is, again, allowing analysts to kind of slice and dice this performance information. In this case, around, you might have different solutions for, in some cases, declining transactions. In other situations, you want to send them for review. So to be able to dissect performance along those lines, we found has really helped our analysts out a lot. And then the next pillar is adaptability. And this ties back to the idea of fraud being an adversarial environment where the fraudsters are constantly changing and evolving their tactics to try to defeat whatever solutions we have in place. And in particular, the main challenge there is that the fraudsters may be changing their tactics at faster timescales than we're receiving information about what was fraud and what was not fraud. And so that poses challenges for kind of classical supervised learning methods where you kind of assume labels of what's fraud and what's not fraud reliably. And so what we found to be really powerful here are essentially unsupervised methods where we can begin to identify anomalous patterns, say unusual spending trends for particular members that might indicate risky situations that we should look into even before we have the feedback about what's fraud and what's not. And then the second idea around this adaptability pillar is automating performance testing. And essentially the idea here is to mitigate this trend that we've observed that the focus is always on how do we get that next rule in to stop the newest trend, and much less often is there time or capacity to go back and kind of cull the system of growing rules that just tends to accumulate over time, right? And which leaves us in the situation with thousands of rules that are then complicated to understand and optimize. And so the method here is really just automating the process of doing that performance evaluation and leveraging the fact that it's much easier to set up a computer to go through and systematically evaluate 1,000 rules and surface the ones that can be removed or modified, and much more efficient than trying to have a person do that manually. And then the final pillar, and one that we really focus on a lot in the financial industry, has to do with governance. And this really challenge really comes to a point because we're bringing in a lot of these modeling and machine learning methods into the rule domain. So that whereas before the kind of documentation requirements around rules were much less than they are now, that essentially the rules are models, and so they're held to the same standard. And so again, this is where we've really tried to leverage automation as much as possible to support the kind of growing challenge of now, instead of maybe a handful of models that we have to document and monitor, there's thousands of rules. And so the two ideas that I want to touch on here, the first is around testing, and in particular, the requirements of our risk management partners to perform really kind of a robust span of tests of all different sorts. So looking at how sensitive are rules to changes in spending behavior or changes in particular risk scores. How would the rules respond to various sorts of scenarios? So for example, COVID being one that actually happened and had a very significant effect on fraud trends. But essentially automating that sort of testing to be able to produce the developmental evidence to show that our system of rules is robust and sound. And then the last point is around automating the documentation piece. And really the goal we're striving for here is that at the end of the day, we want a strategy inventory. So essentially a catalog documenting all of the rules that we have in production now, that we've historically had in production, and essentially all of the evidence that was used to make the decision to put those rules in or to take them out or in any way that they were changed. And so that's the final point. Just to conclude, kind of overall, our idea was to present this hybrid approach and discuss these 6 pillars. And at this point, we're happy to take any questions from the audience. Thank you.